Welcome to another PyPhysicsSandbox tutorial video. This time we're going to look at normal springs. So a spring connects two items, two shapes, with basically a spring. It can stretch, it can compact, but it has a particular length that it wants to be. And you can set the stiffness of the spring, and you can also set how much energy it loses each time it deforms. So I'm going to create a ball and a pivot here. And instead of having the pivot, instead of connecting the ball to the pivot so that the ball can't move, we're just going to have the pivot there, and then we're going to connect the ball and the pivot with a spring. So I want to show you what this looks like ahead of time. So we have the pivot here, we have the ball here. Now the pivot will not move. So when we connect the pivot and the ball with a spring, the ball will fall down, it'll bounce based on the strength that we give the spring, and eventually end up in a more or less stationary position at however much the spring wants to stretch. So we create a spring by giving it a point on the first object that it's connected to, and a point on the second object that it's connected to. Then we give it the length that the spring wants to be. So this is everything else being ideal, how long the spring will end up after all of the oscillations settle down. Then we give it a stiffness. So a high value for the stiffness means that it will stretch less, and a low value for the stiffness means that it will stretch more. Generally these values can be really high, so I'm going to put in 1,000, which is a pretty low value for there. And then we give it a damping value, and the damping value is how much energy it loses over time, and we're going to put 1,000 in for that. Now if I run this, and if I change it so that physics happens, so the ball goes way down. It's still connected to this pivot by the spring, but the 1,000 stiffness for the spring is really, really low. So the spring stretched way down past the 25 that it should have. Now if I make that a lot bigger, like 20,000, now the spring stretches, but then pulls the ball back up. Now the damping value of 1,000 is what settled the spring down. If I'd had that a lot lower, say 100, then the spring is going to retain more of its energy each time and take a lot longer to settle down. So basically you just have to play with these two numbers until you get the effect that you want. And part of it depends on the mass of whatever is being held up by the spring. So my wheel is a radius of 25, and that gives it a certain default mass. If it were a larger ball, then these values might have to be adjusted to get the effect that I want. It's very much trial and error to get the stiffness and the damping to be the effect that you want. But that's how you can have a spring connecting two objects.